This engine moved armies, carried entire industries on their backs, and left behind a sound so iconic it became part of America's mechanical heartbeat. Even today, many of these Detroit diesel two-strokes refuse to die. But how did engines this unstoppable shape history, yet vanish from memory long before their legacy was complete? Let's explore the events that turned these machines into legends, and then almost erased them. The year was 1938. America was still clawing its way out of the Great Depression, and across the Atlantic, Europe was on the edge of a catastrophe. War tensions were rising. Deep inside General Motors, a small engineering team was solving a puzzle that had defeated every major diesel manufacturer in the world. Could a diesel engine be made small, cheap, light, and still powerful enough to change the world? At the time, diesel engines were immovable giants, perfect for ships, terrible for anything that needed to move fast. They were heavy, slow, brutally expensive, and far too massive for trucks or battlefield vehicles. A typical marine diesel of that era weighed several tons and produced maybe 100 horsepower per ton of engine weight. Nobody had figured out how to shrink that down without losing the fundamental advantages that made diesels worth using in the first place: fuel efficiency, reliability, and that legendary ability to run forever under brutal conditions. Their engineers saw something no one else did. What if a diesel engine wasn't just scaled down, but rebuilt from scratch with an entirely new philosophy? What if you could mass-produce diesels like cars, on assembly lines, with interchangeable parts, identical components, and a modular design? It sounded reckless. Maybe it was, but that gamble is exactly what changed history. Instead of following everyone else into four-stroke comfort, GM made a choice that looked insane. They would build a two-stroke diesel. Everyone said it was doomed from the start, but the engineers understood one crucial truth: a two-stroke fires every single revolution. Twice the power strokes, twice the potential. A smaller engine with the heart of a giant. The logic was clear. A four-stroke engine fires once every 2 crankshaft revolutions. A two-stroke fires every revolution. That meant, theoretically, twice the power from the same displacement. In practice, the gains weren't quite that dramatic, but they were substantial enough to matter. You could build a smaller, lighter engine that still produced the power output needed for heavy-duty work. But there was one enormous problem. A flaw so severe it had kept two-stroke diesels out of serious production for decades. How do you clear the exhaust without fuel washing through the combustion chamber? If they couldn't solve that, the design would literally choke itself to death. In a four-stroke engine, dedicated strokes handle intake and exhaust. In a two-stroke, those processes had to happen simultaneously in the brief moment when the piston was near the bottom of its travel. That's milliseconds to evacuate burned gases and fill the cylinder with fresh air. The answer would become the trademark of the Detroit diesel. They bolted a Roots-type supercharger to every single engine. Not for performance, not for speed, for survival. That supercharger force-fed each cylinder with fresh air while clearing the exhaust in a process called scavenging. Without it, the engine wouldn't run for 10 seconds. The blower operated at a fixed ratio to engine speed, driven directly off the crankshaft through gears. Simple, mechanical, bulletproof. And that mechanical blower created something else. A sound unlike anything the world had heard before. A high-pitched, violent whine layered over a rapid-fire exhaust beat. Soldiers would later claim they could recognize that sound from a mile away. The two-stroke scream earned a nickname that stuck like glue: the Screamin' Jimmy. They called the new engine the Series 71, named for its 71 cubic inches of displacement per cylinder. But the genius wasn't in the name. It was in the architecture. Each engine shared the same bore, the same stroke, The same pistons, the same rods, even the same injectors. The bore measured 4.25 inches. The stroke was exactly 5 inches. Those dimensions remained constant whether you were building a 271 putting out 60 horsepower or a massive 16 V71 producing over 600. A mechanic who learned to rebuild a 371 could confidently tear down a 16 V71 towering beside a naval dockyard. The unit injectors were also identical. The piston rings followed the same specifications. The connecting rod bearings used the same part numbers. Even the rocker arms and valve springs were interchangeable across the entire family. It wasn't just engineering, it was a manufacturing philosophy. Diesel engines built with the same logic Henry Ford used for cars. The assembly line at Detroit Diesel looked more like an automotive plant than a traditional diesel shop. Components moved on conveyors. Workers performed specialized tasks at dedicated stations. Quality control happened at multiple checkpoints. And most importantly, every engine that rolled off that line could be serviced with a common inventory of spare parts. Detroit Diesel had no idea how important that decision would become, because in just a few years, the United States would ask them for the impossible. The attack on Pearl Harbor turned Detroit Diesel's experimental project into a national lifeline. The military needed engines, not dozens, not hundreds, tens of thousands, immediately. Engines for tanks, engines for landing craft, engines for PT boats, engines for generators, bulldozers, winches, pumps, anything that moved, lifted, rolled, or charged. The specifications were brutal. Engines had to start in Arctic conditions, survive tropical humidity, run on whatever fuel was available, operate for thousands of hours with minimal maintenance, and be repairable by soldiers with basic tools and limited training. Most manufacturers would have balked at those requirements, but Detroit Diesel had already designed for exactly that scenario. The expectations were high. Could they possibly deliver what was asked of them? The answer shocked even the engineers themselves. By 1943, Detroit Diesel was producing one engine every 10 minutes, 24/7, 365 days a year. Let that sink in. Every time you looked at a clock, another precision-built diesel rolled off the assembly line. The factory employed over 4,000 workers running 3 shifts. Raw materials arrived by rail. Finished engines departed on military transport. The production rate exceeded 57,000 units annually. They went everywhere. Sherman tanks in North Africa, Higgins boats landing troops on D-Day, PT boats streaking across the Pacific, naval generators powering convoys across the Atlantic, construction battalions carving runways out of jungle islands. If the Allies needed power, Detroit Diesel delivered it. The M4 Sherman tank used a 671 producing around 165 horsepower, not the most powerful tank engine of the war, but reliable enough that crews trusted it. PT boats often ran twin 671s or even 12 V71s, giving them the speed to outrun larger enemy vessels. Landing craft used everything from 471s to 671s depending on size and load requirements. And behind the front lines, Detroit Diesels powered the logistics network that kept armies moving. Generators, pumps, compressors, and construction equipment. But the miracle wasn't the production numbers. It was something far more important. These engines survived. Where others failed, Series 71 engines kept running. They started in frozen Alaskan temperatures. They survived desert heat and ran on anything that burned. Diesel, kerosene, improvised fuel mixtures no engineer would approve. They went thousands of hours between serious maintenance. They were repaired in foxholes, on beaches, on war-torn airstrips, often by soldiers with minimal training. Why? Because that's exactly how they were designed. Every component was reachable. Every injector could be swapped within minutes. The supercharger? Practically indestructible. Unit injectors meant no high-pressure fuel lines to rupture. The mechanical governor required no electronics. Even the cooling system was simple. Water jacket, thermostat, pump. Nothing complicated enough to leave a crew stranded. In war, complexity kills. Detroit Diesel built engines for a world where failure was not an option. Then there was the sound. That piercing mechanical scream mixed with rapid-fire combustion. To Allied soldiers, it became the sound of hope. To enemy forces, it became the sound of something else, the unforgiving roar of a machine they could not escape. The distinctive exhaust note came from the two-stroke firing pattern. Each cylinder fired every revolution, creating a rapid hammering rhythm that fired twice as often as a four-stroke. Layer that over the mechanical whine of the supercharger, and you had an audio signature that was absolutely unmistakable. Veterans who'd served in the Pacific Theater could identify a Detroit diesel from hundreds of yards away, even in dense jungle where visibility was measured in feet. And when the war finally ended, Detroit diesel faced a question no one had expected. If these engines had conquered war, what could they possibly do in peace? When the world finally exhaled after years of war, Detroit diesel emerged with something rare, a reputation built not on marketing, but on survival. These engines had crawled up beaches under machine gun fire, powered tanks through burning deserts, kept generators humming during bombardments, and launched fast attack boats into danger again and again. So when peace returned, an entire generation of veterans already trusted one thing. If a Detroit diesel two-stroke could survive war, it could survive anything. That belief would define the next 4 decades of American industry. The 1950s didn't just mark economic expansion, they marked a new hunger for mobility. America was building everything at once: highways, factories, cities, construction fleets, long-haul trucking routes across thousands of miles of open road. Everywhere hard work was being done, these engines appeared. City transit systems discovered that 6 V71 engines in their buses could run 500,000 miles between major overhauls. Construction companies found that 8 V71s in their bulldozers and cranes could operate 10,000 hours before needing significant work. Marine operators reported that commercial fishing vessels powered by Detroit diesels could run for months at sea without shutdown, then fire right back up after sitting idle in port. By the mid-1950s, Detroit diesel recognized an opportunity. The highway trucking industry was exploding, but those operators wanted something different than what construction and marine customers needed. They wanted lighter weight, better fuel economy, engines optimized for sustained highway cruising rather than maximum torque at low RPM. In 1957, Detroit diesel introduced the Series 53. With just 53 cubic inches per cylinder compared to the 71's displacement, the new engine family offered a more compact package. A 6 V53 produced around 165 horsepower while weighing significantly less than a comparable 6 V71. The reduced weight meant better payload capacity, the smaller displacement meant improved fuel economy, and the two-stroke architecture still delivered reliability that four-stroke competitors couldn't match. To highway truckers, it offered a whole new set of advantages. It wasn't as torque-rich as the Series 71, but over-the-road hauling didn't need maximum pulling power at high RPM. It needed sustained cruising ability and the confidence that the engine would start every morning in truck stops from coast to coast. The Series 53 delivered exactly that, proving Detroit diesel could compete beyond their traditional heavy-duty industrial markets. By the 1970s, Detroit diesel unveiled the next chapter, the Series 92, a larger, more powerful family that kept the same modular DNA as the original 71. With 92 cubic inches per cylinder, these engines filled the gap between the 71 and the massive industrial 149 series. An 8V92 produced around 350 horsepower in naturally aspirated form, and substantially more when turbocharged. The 8V92TA with turbocharger and aftercooler could crank out over 450 horsepower. Truckers, fleet managers, and bus companies loved them. And then came the marine world: tugboats, fishing trawlers, Coast Guard cutters, offshore supply vessels. The engines screamed, smoked, and drank fuel like an animal. But they delivered the one thing that mattered: power on demand. The Series 92 arrived during an interesting period in trucking history. The 1973 oil crisis had made fuel economy critical, and Detroit Diesel marketed the 92 as fuel squeezers to emphasize their improved efficiency over earlier designs. Refinements to the combustion chamber and scavenging process helped, but the real advantage was power delivery. A 92 could pull heavy loads without downshifting as frequently, which translated to better real-world fuel economy even if the engine burned more fuel per hour at maximum output. You didn't start a Detroit two-stroke. You awakened it. The procedure became a ritual for operators who ran them daily. Prime the fuel system, set the throttle, hit the starter, wait for that initial puff of white smoke, listen for the blower to spool up, feel the vibration change as the engine catches and settles into idle. Every Detroit diesel had personality. Some liked to be warmed up gently, others fired instantly and idled smoothly from the first second. Experienced operators knew their engines individually and could diagnose problems from subtle changes in sound or smell. Somewhere along the way, the engines became more than just tools. They became characters, mechanical personalities with loyal fans. Owners joked that Detroit diesels didn't leak oil. They marked their territory. Mechanics talked about them like old friends. Engineers admired their simplicity, and enthusiasts created a small but passionate subculture dedicated to preserving the two-stroke scream. The jokes and stories reflected genuine affection. Ask any old-timer about Detroit diesels, and you'd hear tales. The 8V71 that survived being submerged in a flash flood. The 671 that ran for 18,000 hours in a sawmill without major work. The Marine 12V71 that powered a fishing boat for 30 years before finally needing an overhaul. These weren't marketing stories. They were real experiences that cemented the engine's legendary status. There was nothing refined about them, nothing quiet, nothing subtle, but they worked, and that's all that mattered. Then came the problem no one could avoid. The world was shifting toward cleaner emissions, higher fuel efficiency, and quieter highways. And Detroit's legendary two-strokes, beautiful, simple, loud, and smoky, were suddenly out of step with the new rules. Regulations got tighter, standards rose, and the engines that had once powered the world found themselves facing an enemy they couldn't out-engineer: time. The 1970 Clean Air Act marked the beginning of serious federal emissions regulation. Initially focused on automotive engines, the EPA gradually turned attention to heavy-duty diesels through the decade. The problem for two-stroke designs was fundamental. The scavenging process that made them powerful meant some fuel inevitably passed through unburned. That created visible smoke and higher hydrocarbon emissions than four-stroke competitors could achieve. Yet even as production slowed, something unexpected happened. Demand didn't disappear. In remote Alaska, in mining operations, on tugboats, in small towns still running backup generators older than their mayors, Detroit two-strokes kept working and earning paychecks long after their modern replacements had failed. Detroit Diesel tried. They introduced electronic controls, they refined combustion chambers, they experimented with different turbocharger configurations. But the basic physics of two-stroke operation created limitations that couldn't be overcome without fundamentally compromising what made these engines special. By the mid-1980s, meeting emission standards required adding complexity that negated the simplicity advantage. And once you've added that complexity, why not just build a four-stroke? In 1987, Detroit Diesel made a decision that would have seemed unthinkable a decade earlier. They introduced the Series 60, their first four-stroke engine. This was a clean-sheet design featuring electronic controls through the Detroit Diesel Electronic Control System, dramatically improved fuel efficiency, and the ability to meet emission standards that two-strokes simply couldn't achieve. The Series 60 proved successful beyond anyone's expectations. By the early 1990s, it had captured significant market share in heavy-duty trucking. Fleet operators discovered it delivered fuel economy 15 to 20% better than comparable engines while maintaining respectable reliability. But it was a four-stroke. The distinctive scream was gone, replaced by a more conventional diesel rumble. The business landscape was changing too. In 1988, General Motors spun off Detroit Diesel into a joint venture with Penske Corporation. In 2000, Daimler Chrysler acquired the company. The two-stroke era was officially over. The last Series 92 truck engines were manufactured in the mid-1990s. The legendary engines that had defined Detroit Diesel for over half a century were no longer in production. Today, the world is quieter, cleaner, and far more regulated. Detroit Diesel itself has evolved, joined new corporate families, and moved into the era of electronically controlled engines. But the old two-strokes? They're still here. They may not be legal in brand new vehicles, but they're legal in something even more important: memory. Because these engines didn't just power machines, they powered eras. And somewhere right now, in the quiet of an early morning, a mechanic is turning a key. And that familiar whine rises again. There's a moment every engine enthusiast knows. That second when machinery becomes something more than metal. For Detroit Diesel two-strokes, that moment happens the instant they fire. A burst of white haze. The whir of the blower spooling up. The rapid-fire heartbeat of combustion snapping to life. It's theatrical, violent, alive, like the engine is announcing itself to the world. I'm here, and I'm not going quietly. And in that sound, you can hear echoes of everything they powered. The mining trucks, the mountain logging rigs, buses, armies, and so much more. Each one built the world we live in today. In the 1990s, emissions laws tightened again, and the final era of new two-stroke manufacturing came to a close. It wasn't a failure. It was the world-changing direction. Technology moved on. Electronic controls took over. Turbocharging evolved. And the era of mechanical simplicity slowly gave way to digital precision. But look closely, and you'll notice something important. The old engines never disappeared. They simply slipped into the places where only the toughest machines survive. They continue to run because they remain the perfect solution for the worst environments on Earth. In places where failure means catastrophe, people still trust the Detroit Diesel two-stroke. So what do we make of them now? Are they relics, icons, or dinosaurs? Or masterpieces? The truth is probably somewhere in the middle. But history has already decided something important. The Detroit Diesel two-stroke wasn't just an engine. It was an era. And eras don't truly end, they echo. Every time one of these engines fires up on a cold morning miles from civilization, the past comes roaring back to life. As long as even one of these engines runs, the drive that created them, the boldness, the ingenuity, the courage to defy the impossible is still alive.